x coordinate. So in this case, we are now going to write it in the component form, which is going to be vector AB is equal to 4.3 centimeters and 2.5 centimeters. Now, one more thing you need to note. You realize that from this, we realize that in the first quadrant, all of them are positive. Sine is positive, tan is positive, cos is positive. So then it means that we don't have to add any other thing. We don't have to add any other thing to the values in the bracket. I mean x and y values. All right, we don't have to add anything to them. But if it happened to be in the second quadrant, then we might have had to add something to them. We will look at that in the second question. So take note of the second question. So example 2. Express the following. As column vectors. I, PR, 4 centimeters, and then 120 degrees. II, QR equals 6 centimeters, 210 degrees. Then III, BC equals 12 centimeters and 300 degrees. Okay, now we are going to look at the second one. We are looking at the second one, I mean the first question from this set, but there's a second example of this sort. Okay, so let's solve this quickly, and then the other two I will leave for you to try your hands at. Now with the first question, we have PR to be equal to 4 centimeters and then 120 degrees. 120 degrees. Now what does it mean? It means that we are going to first represent this on the Cartesian plane. All right, so we have our Cartesian plane like that, and then this is our y-axis and that our x-axis. Okay, so 120 degrees is bigger than 90 degrees. Okay, and in the first quadrant we have only 90 degrees, so it has to stretch to the second quadrant to get our 120 degrees. So our 120 degrees is going to be somewhere there. Okay, now from here all the way to here is 120 degrees. Okay, so this is 90 and this is 120. So this, the whole of that is 120 degrees. Now we know that we are starting from P and ending at R, and the distance is what? 4 centimeters. Now that we've been able to draw this, we make a triangle with the x coordinate, with the x axis, okay? So that we have a right angled triangle, okay? Now, let's look at this. We realize that from here to here is 90 degrees. So to get this small part, it is going to be what? 120 minus 90. So that this small part here is going to be 30 degrees. Okay, so this small part here is going to be 30 degrees. So then we now have our right angle triangle with this angle with this angle as well as this length. Now from the previous example, we understood that this is our hypotenuse, this is the opposite, and this the adjacent. If that is the case, then once again we can use a trig ratio to find the y as well as the x. So let's see which trig ratio we can use. This is our opposite and this is our hypotenuse. So we use what? So, which happens to be sine 30 degrees equals opposite, which is y, over hypotenuse, which is 4 centimeters. We want y. So like I said earlier, this is over 1. When we cross multiply, it becomes 4 sine 30 degrees, and this is equal to y. Let's go ahead to get our answer. This becomes y equals 4 sine 30 gives us, let's find out what it gives us. We have 4 sine 30, and that gives us 2, exactly 2 centimeters. So this is 2 centimeters. Now let's look at how to get the x. Now once again, we have the opposite and then we have hypotenuse. All right, opposite. Sorry, we have already found y, so we don't need opposite anymore. We have adjacent and then hypotenuse. So we have adjacent and hypotenuse. We are going to use ka. So then this becomes cos 30 degrees equals adjacent, which is x, and then hypotenuse, which is 4. Just as we did for this, we are going to cross multiply. So then 4 multiplies this to give us 4 cos 30 degrees, and that is equal to x. So this implies x is equal to 4 cos 30 is 3.4641. So this is 3.4641. Okay, now this one approximately becomes 3.5 centimeters. So in this case, we are going to have x PR to be, our x is what? 3.5 centimeters, and then our y is 2 centimeters. But this is what happens. You realize that we are dealing with the 4th quadrant. So let's look at sine in the 4th quadrant and also cos in the 4th quadrant. Now, looking at this diagram, we realize that this is the 4th quadrant, and the 4th quadrant has sine to be negative and also has cos to be positive. So it means that the one we use the cos in solving is going to have a positive, it's going to be multiplied by positive. So whatever answer we had is going to be the same thing. But then the one we used sine in calculating for, whatever answer we had, we are going to multiply by negative. All right? And then multiplying the sine by negative means we are going to multiply the y by negative. Okay, so in this case, this is going to be minus 2. Okay, and then the x is going to be maintained because we realize that the cos in the fourth quadrant is positive, so we don't apply any negative to it. We maintain it as it is. So that is how we get the vector in component form. Thank you very much for being with me through this period. Now, there's another approach that we can use. But before we move on to the second approach, remember the other two questions that I gave under example 2. They are yours to do. So you are going to do them on your own and make sure to get the right answer. The answers you are going to get from II and III, I will provide it in our next meeting so that you compare with what you have and then see if you did the right thing. Now there's another approach that we can use. Now with that approach, it happens to be easier and faster. But it pays to understand both approaches. Okay. The reason being because when we move further, we will be making more use of this vector bearing approach, the component form or the Cartesian plane form. We'll be using it most often when we enter the bearing aspect of this. Okay, so then if you know both approaches, it is going to be very, very, very helpful. Okay, now let's look at the other approach that we'll be using. Let's look at the other. Okay, so now with the second approach, let's say method 2. Method 2. We have PR to be equal to 4 centimeters and then 120 degrees. Okay, now this one, you just take some 2 simple steps and then you get your answer. All you have to do with the second approach, I've already solved this particular question using the previous approach. It happens to be the first approach. Now with the second approach, this is all you have to do. You have your PR to be equal to, you take the first figure you have there, which happens to be the distance or the magnitude, and then apply the sign. Okay, so in this case it becomes 4 sine 120 and then 4 cos 120. All right, so that is all. Just punch this on the calculator and then you end up getting your answer. Now in this case, you don't need to take note of the all-silly tomcat thing, the quadrants and their signs in it. Automatically the answer given or that you'll be getting from the calculator will have the original answer or the original sign that it has to be with. So in this case, 4 sine 124 sine 120 gives us 3.4614. 3.4641. And then 4 cos 120 also gives us -2, straightforward. Are you okay? So there is no need using the signs in each quadrant to get the right value. Unlike this one, you have to go through this long process to get the value and also apply the all-silly tomcat to get the signs right. This one, all you have to do is to punch it on the calculator and you get your values. It's as simple as that. So then let's look at the other one. Let's say we have MN 17 kilometers and then 220 degrees. Now let's look at this. This happens to be 17 kilometers and then 220 degrees. This time around it's in kilometers, but it doesn't change anything. Just remember the kilometers are the signs or the measure of the whatever you're going to use is going to be in the answer. So in this case, it would have been centimeters. Centimeters. Are you okay? So then it doesn't really change anything. The only thing it applies is the sign or the values given from the questions given. Okay. Now in this case, we have 17 sine 220 degrees. And then 17 cos 220 degrees. Okay. Now 17 sine 220. When we punch on the calculator, we have 17 sine 220 given as minus 10.9273. And then 17 cos 220 also gives us minus 13.0227, and that is it. You don't have to go through much procedures or much steps, just 2 steps and your answer is given. Alright, so this is how to write the component form of a vector given the question in the magnitude bearing form. Okay, so now these are the 2 approaches we can use in finding the component form of a vector given the magnitude bearing form. Now this is the first approach. This is a magnitude bearing form. We used this approach in getting the answer. That is the method 1. And then we also used the second method, which is this approach. That is the same question we solved using the method 1. And that is the answer. We realized that we just went through 2 steps and we had the answer. Now I went through the first approach because we'll be coming back to use those steps. We'll be coming back to use that approach and finding something when we move further. So it is good to understand that. Though it is a longer process, it is good to understand that. Okay, so let's go further. Let's look at. Okay, so the next thing we are going to look at is the magnitude or the modulus of a vector. Like I said earlier, the magnitude, another name for the magnitude is the modulus, or you can also say the length or the distance between 2 points. Okay, so the modulus or the magnitude of a vector. Okay, now assuming vector AB has coordinates, vector AB has coordinates x, y, then the length or the magnitude is given as AB, like that. So the length or the magnitude is represented by this, and this is equal to x squared plus y squared. So this is how the magnitude is represented. The two lines before and after the vector. Okay, so the vector is going to be in between those two lines. Okay, and that is what is used in representing the magnitude. So assuming we have a question such as this. We have uv, that is vector uv, to be equal to minus 7 and then let's say minus 8 and then 6, and we are to find the modulus. Find the modulus of vector uv. Then the solution is going to be like that. We know the uv is minus 8, 6. And that implies that the length, of uv is going to be equal to minus 8 squared plus 6 squared. Let me bring it to the top. Minus 8 squared plus 6 squared, and this equal to 64 plus 36, and this is going to be square root of 100, and that is equal to 10 units. So that is how the magnitude is done. Let's take another example. Example 2. If vector AB is equal to 3, 4, and AC, vector AC is equal to 12 minus 9, comma, find and good. So this is the question. Now I'm going to solve AB and then you will solve AC on your own. So the solution goes this way. We say AB, that is vector AB, is equal to 3, 4. And then vector AC is equal to 12 minus 9. So then the length of AB, or the modulus or the magnitude of vector AB, becomes 3 squared plus 4 squared, like that. Now I bring the bracket because not all the time that you have positive. Sometimes you have negative. So when you bring the bracket, it makes it perfect. Now this becomes square root of 9 plus 16, which is square root of 25, and that is equal to 5 units. So AB, the modulus of AB is 5 units. So you are going to solve the AC. Okay, I would solve the AC and then I'll give you one to do on your own. So then we have AC, that is vector AC, the length of it. It is going to be 12 squared plus minus 9 squared. Now 12 squared is 144, 9 squared is 81, so square root of it. Now 144 plus 81 gives us 225, and then square root of 225 is equal to 15 units. Okay, so that is it. That is how to get the modulus or the length or the magnitude of a vector. So while on your own, I'll give you these questions to try and hands at. And that brings us to the end of today's class. So okay, so example 3. And like I said earlier, this is going to be your assignment. You have to find the magnitude of the following. I. You have PQ to be minus 12, 5. And then you have BC to be 5, 8. Then you have CD to be 9 minus 1, and IV RQ to be minus 6 minus 12. Okay, so this brings us to the end of today's class. God willing, the next time we'll be continuing with the negative or the inverse of a vector, and then we'll continue from there. Thank you. This is Henry Edem. Bye-bye.